All right. The past couple of days, I have given you that worksheet 14.1. I wanted you to do some exploring about what the graphs of sine and cosine look like. Now, hopefully you realize, or hopefully your graph looks something like this when you were done for the graph of sine. My expectation is that you drew those 30, 60, 90s, those 45, 45, 90 triangles. You should be able to find the exact value. But then I wanted you to change it into a decimal because it's a whole lot easier to graph a decimal approximation than something like root 2 over 2. Now, with that said, we notice, or we should notice, that both sine and cosine have this funky looking wave to them. Both sine and cosine ended up to be between what values? 1 and -1. That shouldn't be surprising. We had that conversation last chapter that sine and cosine could only be values between -1 and +1. I would never have the sine of an angle be 12 or the sine of an angle be -42. The sine and the cosine always had to be between -1 and +1. Notice that my sine graph crosses the x-axis at 180 and 360. Notice that I could have picked any angles that I wanted. I could have picked -70. I could have picked -13.35. I could pick any angle that I wanted, so my domain was all reals. Now, asymptotes is another thing that I had some conversations with people about. Asymptotes are lines that my graph approaches but never touches. Lines that my graph gets closer and closer and closer to without touching it. Do sine and cosine have any lines that they get closer and closer and closer to but never touch? No. Sine and cosine, neither of them has any asymptotes. Now, sine and cosine look very similar, but there's a major difference. Does anybody remember what the difference between sine and cosine is? Okay, well, not really flipped. They're not really flipped. Matt? Okay, all right. I like your thinking. Sine starts at 0, 0. Sine crosses the x-axis at 0, 180, 360. Look at our graph of cosine. Your graph of cosine should look like this. Does cosine start at 0, 0? No, cosine actually starts at the top. Cosine starts at the maximum value, and it crosses the x-axis only at 90 and 270. And that wave, that pattern continues to go over and over and over again. Sine and cosine look very similar, except sine starts at 0, 0, cosine starts at the maximum value, the top. All right, now let's have a little bit more discussion about some things with sine and cosine. So, hopefully we realize that when I think about sine and cosine, my sine graph starts here, it goes to the top, it comes back down to the x-axis, it goes down to the bottom, and it comes back up to the x-axis. And then I'm going to put arrows on the ends because it happens over and over and over and over and over again. But cosine starts at the top, goes down to the x-axis, bottoms out, goes back up to the x-axis, and goes back up to that maximum value. And obviously arrows on both ends because it does it over and over and over and over and over again. Now, sine, as I said, starts at the middle, starts at 0, 0, goes to the top, back to the x-axis, down to the bottom, and back to the x-axis. When I get back to this spot at the x-axis, it's like starting the same piece all over again. Does that make sense? So if I'm at 0, 0, if I'm at this point, it's like being at the same point. One complete movement through the pattern is what we call a cycle. So in other words, this is one cycle of my graph of sine because I just repeat this piece over and over and over again. I could copy it, move it over here. Copy it, move it over again. I repeat this over and over and over and over. This is one cycle of my graph. Now, the length on the x-axis of that cycle The horizontal length of this is what we call the period of the graph. It's what we call the period of the graph. And for cosine, you'll notice that it starts at the top, goes to the x-axis, goes to the bottom, back to the x-axis, and back to the top. This point right here is exactly in the same place in this wave as my y-intercept was, because I would start over by going back down again. This is one cycle of cosine. I could copy this, move it over here, copy it, move it over again. It repeats over and over and over again. Now, once again, the length of this x-axis for the one cycle is what we call the period of the graph. Yes, sir?
You put like the 2 spots at the bottom posts instead of the top posts. And make it a cycle, we call that a cycle instead of.
Could these be down here? Is that what you're asking? Yes, we're going to talk about that in a couple of days, what happens when that's the situation. Okay? All right? Yes. There are a lot of, because this pattern repeats itself over and over and over again, there are lots of different ways to look at these. Okay? Yep, and we will start to dissect those in the next few days. All right? Now, some characteristics of these graphs, some things we need to look at. So first of all, domain for sine and cosine, all real numbers. I can pick any angle I want. It's a beautiful thing. My range, I know that sine and cosine have to be between -1 and +1, so my range for sine of x and cosine of x is -1 is less than or equal to y, which is less than or equal to 1. The amplitude, this is a new word. Amplitude is something that is very special for sine and cosine graphs, trig function graphs. The amplitude is half the difference of the maximum and the minimum. So it's the half. It's half of the maximum subtract the minimum. Really what the amplitude is the distance from the middle of my graph to the maximum value, or from the middle of my graph to the minimum value. The distance from the middle to the top, or from the middle to the bottom. That is what the amplitude is. Now, this function is what we call periodic, which means that it repeats a pattern over and over and over again. The shortest part, one piece of this graph, is what we call a cycle. It's one movement through the pattern. The horizontal length of that cycle is called the period. All right, the x-intercepts for sine. I know that when I had you do that worksheet 14.1 yesterday, I had you do it in degrees because we feel more comfortable in degrees. But we're going to be working primarily in radians when we work with anything with trigonometry. So for sine, my x-intercepts were at 0 pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi. I will show you how to find them. And my x-intercepts for cosine, are at positive pi over 2, 3 pi over 2, 5 pi over 2, or negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. And I, once again, will be showing you how to find those. Don't get too worried about this or concerned about this right now. Yes? Better? All right, are we ready? All right, so on your worksheet, you graph the most basic sine and cosine, okay? We are going to adjust that basic sine and cosine graph today. All right, so everybody's good? Okay. Okay, so here we go. All right, now, the ones that you graphed on pre-worksheet 14.1, worksheet 14.1 was y equals sine of x and y equals cosine of x. All right, what we're going to be doing today is we're going to be moving towards looking at the graph of y is equal to a sine of bx and y is equal to a cosine of bx. So now we should really realize that this, because it starts at 0, 0, is y is equal to a sine of bx. And this, because it starts at the top of the graph, has to be y is equal to a cosine of bx. All right. The number a and the number for b are going to change this graph. The number for a and the number for b are going to change the appearances of this graph. Now, the a value, the leading coefficient, the a value, will remind you of amplitude. A will remind you of amplitude, and hopefully we remember amplitude is a distance from the middle of my graph to the top, from the middle of my graph to the bottom. Amplitude is from the middle to the top and from the middle to the bottom. The amplitude is the absolute value of A. The amplitude is the absolute value of A. That's how we find the amplitude. The distance from the middle to the top and the distance from the middle to the bottom. So in other words, the distance on my graph from the middle of my graph to the top is a distance of A units, and from the middle to the bottom of my graph is a distance of A units as well. Cosine is the same thing. The distance from the middle of my graph to the top of my graph is A units. The distance from my graph to from the middle of my graph to the bottom of my graph is A units also. So the A helps me find my maximum value and my minimum value on the graph. Yes? Nope, and I will show you that in a minute. Yep. All right, now my B value. My B value helps me to find the period. My B value helps me to find the period, the horizontal length of the cycle. The period is 2 pi divided by absolute value B, and I commented we're going to be in radians. 2 pi is really the same as what? 360. Okay, so if I were in degrees, that would be 360 divided by absolute value B. But the period is 2 pi divided by the absolute value B. Now, when I look at sine, when I look at a graph of sine, it starts here at 0, 0. It goes to the top. It goes back to the x-axis. It goes all the way to the bottom, and it goes back to the x-axis. This is where I end one cycle. That is one cycle of my graph of sine. One cycle of my graph of sine. This point is in exactly the same place in that pattern as 0, 0 was. Now, that means that the distance from here along the x-axis is the period of that graph. So this point right here is at the period of that graph, which I'm going to call P. Yes, sir. Certainly. All right. For cosine, cosine starts at the top, and it goes to the x-axis, then it goes all the way to the bottom, then it goes back to the x-axis, and it goes all the way to the top. This is one cycle of cosine. This is one cycle of cosine, which means that the distance along the x-axis to get through that one cycle is the period. So this is going to be the period P. Does that make sense to everybody? Okay. And I find that period by doing 2 pi divided by the absolute value of B. Okay. Now, last thing that I need to know about my graphs before we're ready to put some numbers in and try this out. I need to take each cycle and I need to break that x-axis into quarters. So in other words, as I'm looking at this period, if I were right here on my graph, how close am I to getting to the end of the cycle? I'm halfway there. So I'm halfway to P. How close am I if I'm right here? A fourth. So I'm a fourth of the way through the cycle. I'm a quarter of the way to P. And what about right here? 3/4 of the way through the cycle. So I'm 3/4 of the way to P. Yes, sir.
What's the B?
The B is the number in front of your X. So to find the period, I do 2 pi divided by the absolute value of that B.
How do we know what B is?
I'm going to get there in a second. Yep, this is just the general explanation. Generally what it looks like. When you get some numbers in there, you're going to be a whole lot happier. Okay? Yes, sir.
So question, when you find P, you take that and multiply by like 1/4.
I'm going to, yep, you're a step ahead of me. Yep, perfect thinking. Perfect thinking. Now, this is one cycle here. And if I were right here, how far the way through the cycle am I? Halfway, so this is halfway to P. How about here? A quarter of the way through the cycle, so this is a quarter of the way to P. And right here, 3/4 of the way through that cycle, so this is 3/4 of the way to P. I know, we're excited to plug in numbers, and so am I. All right, so far so good. Now, there are 5 key points on the graph. You know, when we did our worksheet 14.1, when you did worksheet 14.1, I made you plot a whole boatload of points, hoping you'd play connect the dots and you'd get an idea of what this graph looks like. But now that we know what the pattern is, for sine and cosine, we only need to graph 5 points each time. We only need to graph 5 key points each time. And those key points are going to be our maximums, our minimums, and our x-intercepts. 5 points to make one cycle of sine, 5 points to make one cycle of cosine. The maximums, the minimums, and the x-intercepts. Okay, now that means sine starts on the x-axis. It goes all the way to the maximum. It comes back to the x-axis. It goes all the way to the minimum. And it comes all the way back to the x-axis. Those are my 5 key points. Those are my 5 key points. And then, all right, for cosine, it starts at the maximum. It goes to the x-axis. It goes to the minimum. Goes back to the x-axis. And goes all the way up to the maximum. Those are my 5 key points that I need to graph every single time I graph cosine. Questions with that? Okay, let's see what this looks like. Okay, get some numbers in there. I think we're going to feel a little bit better about it. Okay, so we're looking at this. Give the amplitude, the period, the 5 key points on the graph, and graph y is equal to sine of 3x. Okay, so the first thing I need you to do, is directly above y is equal to sine of 3x, every single time write y equals a sine of bx. That is our function. Because I need to realize what number am I going to use for A? 1. And what number am I going to use for B? 3. All right, because in front of that sign, we know there's nothing there, but we know it's a 1. So my A value is 1 and my B value is 3. Perfect. A reminds me of what word? Amplitude. And how do I find the amplitude? Absolute value of A. Okay, so the absolute value of 1 is 1. Now 1, the amplitude is the distance from the middle of my graph to the top and the distance from my middle of my graph to the bottom. So from the middle of my graph to the top is 1 unit. From the middle of my graph to the bottom is 1 unit as well. Perfect. All right. What does the B help me with? The B helps me find the period. And how do I find the period? 2 pi over the absolute value of B. So 2 pi over the absolute value of my B value of 3, which is 2 pi over 3. Which means from the start of my first cycle To the end of my first cycle on the x-axis, I go a distance of 2 pi over 3. From the start of my first cycle to the end of my first cycle along the x-axis, I go a distance of 2 pi over 3. So the period of my graph is 2 pi over 3. Now, as I commented before, I need to break that x-axis up into quarters. So, Justin had already commented, wouldn't it be smart to do this? And I totally agree. We're going to break it into quarters. So I'm going to take a quarter of that period 2 pi over 3. I'm going to take always a half of my period 2 pi over 3. And I'm going to take 3/4 of my period, which in this case is 2 pi over 3. All right. So what is a quarter of 2 pi over 3? Yes?
How do you know that 2 pi over 3 is a little bit?
I am choosing it. Yep. We're not going to use graph paper. We're always just going to draw these axes. I'm picking it over here because I want to spread my graph out as much as I possibly can. Okay? Do not use graph paper on these graphs. Draw your 2 axes freehand. This is one rare case where I'm going to tell you don't use graph paper. Okay? Graph paper makes it a mess. Makes it a mess. Those little boxes really have issues with it for us. Okay? All right. So, what is a quarter of 2 pi over 3? Pi over 6. Yep, 2 pi over 12. 2 twelfths is 1/6, so that's pi over 6. What's a half of 2 pi over 3? Yep, my 2's are going to cancel. 1/3 pi is just pi over 3. All right, what about 3/4 of 2 pi over 3? Yeah, 3's are going to cancel, so I get 2/4 pi, right? Well, 2/4 is a half, so that's pi over 2. All right, I like to make it so that I make my picture look as nice as possible, and I'm not an artist, so I know that this is not my forte. But I know that halfway to 2 pi over 3, halfway to 2 pi over 3, I should be at pi over 3. Then I like to shorten it up a quarter of the way to 2 pi over 3, I'm at pi over 6. And 3/4 of the way to 2 pi over 3, I'm at pi over 2. We okay with that? All right, now I need to remind myself, where does sine start? At 0, absolutely. Pattern's the same every time. Sine always starts at 0. Sine always starts at 0. It goes up to the maximum, the top of that graph, back to the x-axis, down to the bottom, down to the minimum value, and then back to that x-axis. So here is one cycle of sine, a nice, beautiful wave curve. And I know I'm going to put arrows on each end because it keeps repeating that over and over and over and over again. All right. Now, a couple things. I like to skip down to my 5 key points. Do I see the 5 points on my graph? Yeah, give me one of those 5 key points.
0, 0.
Absolutely. Love it. First one, easiest one, 0, 0. All right, where do we go after 0, 0?
1 pi over 6.
Whoa, careful.
Over 6 pi.
Careful. How do I write that point? Pi over 6, 1. And it's really easy to get them all mixed up. So I go to the right pi over 6 and then up 1. So my point is pi over 6, 1. All right, give me that third point, Hunter. Can you give me another point?
Pi over 3 is 0.
Pi over 3, 0. Yep, I go to the right pi over 3, so I'm at pi over 3, 0. All right, Brianna, can you give me another one?
Pi over 2, -1.
Beautiful. Pi over 2, -1 right here. And finish it off for us, Lena.
2 pi over 3, 0.
Beautiful. And my last x-intercept, 2 pi over 3, 0. My 5 key points. All right, what about asymptotes? Are there any lines that my graph approaches but never touches? Nope. Sine and cosine never have any asymptotes. We're just going to write none. Sine and cosine never have any asymptotes. All right, how about the domain? All real numbers. I can always pick any angle I want. So all real numbers for any sine and any cosine graph. How about my range? Where are my y values? Yeah, absolutely. Smallest one's -1, biggest one's +1. So y is greater than or equal to -1, less than or equal to +1. Any questions with that one? All right, let's skip to C. All right, let's skip to C. Notice what's different in C. Oh yeah, we got crazy looking stuff in there with pi over 2, but fundamentally what's different about C? It's cosine, not sine. That's a huge difference. Okay, so directly above it, first of all, I want to key in, it is y is equal to a cosine of bx. Y is equal to a cosine of bx. Okay, so what number do I have for a? 3. And what number do I have for b? Pi over 2. All right, a reminds me of what, folks? Amplitude. A reminds me of amplitude. And how do I find the amplitude, Aaron?
You have to go up 3.
Beautiful. The amplitude is the absolute value of A. So the absolute value of 3 is 3, which means from the middle of my graph to the top of my graph is 3 units. From the middle of my graph to the bottom of this graph is 3 units as well. All right. What do I use the B for, Ashlyn? What do I use the B for?
To find the period.
And how do I find the period?
2 pi over the absolute value.
All right, so 2 pi over the absolute value of, what is my B? Pi over 2. Well, what's 2 pi divided by the absolute value of pi over 2? Okay, now let's walk through it. We have 2 pi over, what's the absolute value of pi over 2? Pi over 2. How do I divide by a fraction? Multiplied by the reciprocal. So that's 2 pi times 2 over pi. What happens? The pi's cancel, and 2 times 2 is? 4. The period is 4. Gotta get that fraction work right. Gotta get that fraction work right. So, from the beginning of my first cycle to the end of my first cycle is a distance of 4 units along that x-axis. Yes, sir?
Just a question, if it's like pi over like 3, would it always, the pi's are always going to cancel and then you multiply it by the numerator denominator, multiply them, right?
Yes. Yep, that is true. All right, now, once I know that the distance along the x-axis is 4, and I know that my period is 4, I want to break that x-axis into quarters. Breaking that x-axis into quarters. So I have a quarter of 4, a half of 4, and 3/4 of my period 4. All right, easy one. What's quarter of 4?
1.
Half of 4. And 3/4 of 4. Beautiful. All right, so I always like to start with the halfway point to get my graph looking nice. So halfway to 4, I'm at 2. A quarter of the way to 4, I'm at 1. And 3/4 of the way to 4, I'm at 3. Nice ones to put on this time. Nice ones to put on this time. All right, making my graph. Graph is cosine. Where does it start? At the top. It starts at the maximum value. So my cosine starts all the way up here at the maximum value and follows the same pattern every time. Starts at the maximum, goes to the x-axis, down to the minimum, back to the x-axis, and up to the maximum. So, x-axis, down to the minimum, back to the x-axis, up to the maximum. Arrows on both ends. It repeats itself over and over and over and over. All right, asymptotes. None. Sine and cosine do not have any asymptotes. No lines that my graph approaches but never touches. 5 key points. Ben M, give me some 5 key points here. 0, 3. I go up 3 to start. 0, 3. Got another one? 1, 0. Perfect. All right, Marissa D, got another one for me? 2, -3, I love it. And what's another one? 3, 0. All right, folks, where's the last one? 4, 3. 4, 3. All right, and what is my domain? All reals. Chelsea, what is my range?
-3 is less than y is less than
Beautiful. My y's go from -3 to +3 because my a value was 3. Are we okay with that? Questions with that one? All right. Continuing on then. All right, so we looked at graphing them. Now we're going to write the equation in the form y is equal to a sine of bx with the given amplitude and period. Okay? They told me that the equation they want me to use is y is equal to a sine of bx. And they told me that the amplitude is 2. Amplitude helps me with which letter? A. The amplitude is equal to the absolute value of a. So if my amplitude is 2, if 2 is equal to the absolute value of a, what is a? 2. Technically, plus or minus, right? Today we're going to assume it's positive. We're not going to deal with any negatives today. We'll get to that in a couple days. Right now we're going to assume my a value is a positive 2. So y is equal to my a value of a positive 2 sine of, what am I going to use to find the b? The period, absolutely. Remember that the period is equal to what? How do I find the period? 2 pi over the absolute value of b. But they told me that the period's 8 pi. So that means 8 pi should be equal to 2 pi over the absolute value of b. All right, what am I going to be doing in that case to start solving for b? Yep, multiply both sides by what's in my denominator, which is the absolute value of b. So we have 8 pi, absolute value of b is equal to, my absolute value of b is cancel, and I get 2 pi. All right, what am I doing to get b by itself? Yep, divide both sides by 8 pi. So my 8 pi's are going to cancel, and the absolute value of b is equal to, what's 2 pi divided by 8 pi? Yeah, pi's cancel, and 2/8 reduces to 1/4. So if the absolute value of b is 1/4, b is 1/4. And once again, we're going to work only with positives today. Work with only positives today. So b is 1/4, and then I have an x. So y is equal to 2 sine of 1/4 x. Are we okay with that? Does that make sense to us? All right, frequency. Frequency. The frequency is the reciprocal of the period. So I take the period and do what with it? Flip it over. Okay, so let us remind ourselves, how do I find the period? 2 pi over the absolute value of b. So how would I find the frequency? You bet. It's always the absolute value of b over 2 pi. Or if I were in degrees, absolute value of b over 360. Absolutely. Absolutely. Questions with that? All right.